Hello friends, myself Rajendra Mahajan presenting my video on Laplace Transform of Integral from Laplace Transform a revised series. A statement: if Laplace of f of t as f bar of s given or we can obtain, then Laplace transform of integration from 0 to t of f of t dt means the Laplace of integral is given by or obtained as 1 by s into f bar of s. What is f bar of s? That is the Laplace transform of the given function f of t. This is the statement of this Laplace transform of integral theorem. Then using this we try to solve some problem. Simple problems I have considered. Find Laplace of the following. Number 1, integration from 0 to t of e raised to bt with respect to t. Integration from 0 to t e raised to bt dt. Second, integral from 0 to t of sine omega t minus alpha with respect to t. Third, integral from 0 to t of cos square dt. Fourth, integration from 0 to t of sin h to t dt. Fifth, integration from 0 to t of e raised to t cos h a t, like this. There are total 7 examples. I will go one by one. First one, find Laplace of integration from 0 to t of e raised to bt dt. Therefore, first step we have to find the Laplace of that function f of t. Here that function f of t is e raised to bt. As per the standard result, its Laplace is 1 upon s minus b for s greater than b. And we call this as f bar of sc. This is the first step. In second step, we apply that theorem. Therefore, Laplace of integration from 0 to t of e raised to bt with respect to t as 1 by s into that f bar of s. Therefore, we substitute the value of f bar of s so that we get that answer as 1 by s into 1 upon s minus b as the Laplace transform of that integral. First example is completed here. Then second example, find Laplace of integration from 0 to t of sine omega t minus alpha with respect to t. Therefore, here function is sine omega t minus alpha. To find its Laplace, we have to first expand it by sine a minus b trigonometric formula. It is sine a cos b means sine omega t cos alpha minus cos omega t sin alpha. Sin alpha and cos alpha are the constant terms. Then we take the Laplace on both sides. Therefore, Laplace of left hand side is equals to Laplace of right hand side, and that is equals to cos alpha we take outside, Laplace of sin omega t minus sin alpha into Laplace of cos omega t. Then using the standard results we get this is equals to cos alpha as it is, no change. Laplace of sin omega t is omega upon s square plus omega square, standard result, minus sin alpha also as it is, and Laplace of cos omega t as s upon s square plus omega square, and we call this as f bar of s. Or we can take LCM as s square plus omega square, so that in numerator we have omega cos alpha minus sin alpha into s whole divided by s square plus omega square, and this is f bar of s. Then applying that theorem, we get Laplace of integration from 0 to t of sine omega t minus alpha with respect to t is equals to 1 by s into f bar of s, and therefore substituting the value of that f bar of s, we get the required answer. Therefore, as there are total 7 examples, watch the video up to end. Watch the video completely for better understanding, clearer understanding. Here the second example is completed. Then we go for the third example. Laplace of integration from 0 to t of cos square t with respect to t. Therefore, to obtain Laplace of cos square t, we first convert it as standard trigonometric result 1 plus cos 2t divided by 2. This is the first step. 1 plus cos 2t divided by 2, and then we take Laplace of cos square, means the Laplace of this right hand side term. 1 by 2 we take outside. Laplace of 1 plus Laplace of cos 2t. Taking individual Laplace, we get 1 by 2 as it is, no change. Laplace of 1 is 1 by s, and Laplace of cos is s upon s square plus 2 square, means 4, and we call this as f bar of s, say. And then applying that theorem, therefore Laplace of integral of cos square t with respect to t as 1 by s into f bar of s. I have taken, or I have considered a very simple example to know the basic of this theorem. Therefore 1 by s into 1 by 2, 1 by s plus s upon s square plus 4 as the required answer. Then example number 4th, Laplace of sine hyperbolic of 2t with respect to t between 0 to t. It is 1 by s into f bar of s. F bar of s means the Laplace of sine hyperbolic of 2t. This is the another way to write that Laplace transform. Laplace of sine hyperbolic is a here, a is here 2 upon s square minus 2 square. Required answer. In 2 steps only we get the answer. 5th, Laplace of integration from 0 to t of e raised to t into cos hyperbolic of t with respect to t. Here there are 2 theorems we have to apply. First, we find Laplace of cos hat, and then by shifting theorem we get the Laplace of that e raised to t into cos hat, and finally we apply that integration theorem. Therefore, Laplace of cos hat as s upon s square minus a square with the condition s greater than a. We call this as f bar of s. Then by first shifting theorem we get the Laplace transform of e raised to t into cos hat, as it is multiplied by e raised to plus at. We have to replace f bar of s by s minus 1 in that f bar of s. Therefore, answer is s minus 1 whole divided by s minus 1 whole square minus a square. And then we go for the next step, last step, Laplace of integration from 0 to t of that function e raised to t cos hyperbolic of at and its integration with respect to t as 1 by s into f bar of s, and therefore answer is 1 by s multiplied by that previous term s minus 1 upon s minus 1 whole square minus a square. As a final answer, final Laplace transform. Then sixth one, find Laplace of integration from 0 to t of t raised to n with respect to t, where n is positive integer. Here, as per that condition, we first find a Laplace of t raised to n. Whenever it is positive integer, its Laplace transform is given as, therefore Laplace of t raised to n, when it is positive integer, n is positive integer, it is n factorial divided by s raised to n plus 1, and we call this as f bar of s if n is positive integer. And then applying that theorem, Laplace transform of integral of t raised to n as 1 by s into f bar of s, and therefore the answer is 1 by s into value of f bar of s is n factorial divided by s raised to n plus 1. And then last example, Laplace of integration from 0 to t of t raised to 3 by 2 into e raised to 2t with respect to t. Therefore, first we consider function f of t as t raised to 3 by 2, then we apply first shifting theorem, and then finally, therefore, Laplace of t raised to 3 by 2 as, here it is not positive integer, therefore gamma n plus 1 divided by s raised to n plus 1. As per that, it is gamma 3 by 2 plus 1 divided by s raised to 5 by 2. Then the value of gamma n plus 1 is n gamma n. As per that, it is 3 by 2 into 1 by 2 into gamma 1 by 2 and divided by s raised to 5 by 2. It is 3 by 4. Value of gamma 1 by 2 is square root of pi and whole divided by s raised to 5 by 2. And we call this as f bar of s. First step. Then second step, we apply first shifting theorem. Therefore, it is Laplace of t raised to 3 by 2 into e raised to 2t is nothing but f bar of s minus 2. Therefore, replacing s by s minus 2, we get 3 by 4 square root of pi s minus 2 raised to 5 by 2 as a new f bar of s, say. And then final Laplace of integral of t raised to 3 by 2 into e raised to 2t as 1 by s into f bar of s. And therefore, final answer is 1 by s into that previous value or previous step. It is 3 by 4 into square root of pi divided by s minus 2 whole raised to 5 by 2 as the answer. Therefore, like this I have discussed total 7 examples. Please like my video, hype it, as well as share, subscribe to my channel and press the bell icon to receive the notification. Thank you. Thanks for watching.